Yo, word up my peeps. So we're in chapter 4b. Last part we talked about the history, how we discovered the atom. Now we're looking at where do electrons hang out. Well, electrons have their own address in an atom. And where they're located partly is determined by the amount of energy that they have. More energy, higher level. Less energy, lower level. Now there's 4 parts to an electron's address, really. And they're made up of 4 quantum numbers. Don't panic, okay? I'm not having you memorize the N, L, M, S. I'm not. But you do need the 4 parts. N is the principal. That's our basic energy level. Okay, how far from the nucleus? The angular, the L, is the shape of the orbital, the shape of the region that the electron is in. M is the magnetic, which is the orientation in space. S is short for spin. How is the spin of the electron? So now there's the 4 parts. We can look at our basic energy level, our principal quantum number N. It's our principal energy level. The higher the level, the further away you are from the nucleus. That's pretty much it. So of course, naturally, the further you're away from the nucleus, the levels get bigger. And that'll be a key thing because you can actually fit more electrons in the higher level. Now, we also have sublevels in there. Sublevel quantum number, aka the azimuthal quantum number. Oh, I can see it now. Oh, those $25 vocabulary words. Yeah, I know. Don't panic too much. Think about it as the sublevel. So you have your basic energy level, you have your sublevel. In the sublevel, you can have different regions called orbitals that are in there, okay? So for each value of n, they range from 0 to n minus 1. Well, I'm not going to worry too much about it. Now, the number values can be described by the following letters, which people find a lot easier: S, P, D, F, G, H, I. Now, we're not going to memorize all those letters. Now, S, P, D, F, that's what we're going to spend a bunch of time working on. Wait, what do you mean by S, P, D, F? Well, it's the shape of our sublevel's orbital, okay? Now, you can have more than one kind of sublevel orbital inside your basic energy level. So here's S, and you notice, hey, it's shaped like a sphere. Yes, exactly. Then we have the P's, then we have the D's, and then we have the F's. And you'd say, well, wait a minute, not all of them look totally different. You're right. A bunch of them happen to do with how are they arranged in 3-dimensional space. So how do those orbitals fit together? This is where life gets interesting, because you really have to think 3-dimensionally. Here you have a nucleus. Surrounding the nucleus you have level 1, sublevel S. Now that's the only sublevel that exists at level 1. Sublevel S, that orbital. Then you have 2s. So level 2, sublevel S. Every level has a sublevel S to it, an orbital. And that's the s orbital. Then we can talk about 2p. And you may notice it sort of looks like a flower. Yeah, in a way it does. And if you notice, it's inside of 2s, inside of 1s, right. And some of it is sticking outside of the 2s as well. Remember, these are regions where electrons are most likely to be found in. Now, the noodle baker is that all this is inside the 3s. These are inside of each other. And you're sitting there thinking, but wait a minute, you've got electrons running around loose in there. Right, not that many, but yes. How is it that they don't crash into each other? The space is huge. Remember from our last chapter, an atom is mostly empty space. So the chances of electrons smashing into each other, it's really not happening. Not on a regular, okay, it didn't erase here. But that's what's going on. And it's absolutely amazing. It's a testament to God's creative capabilities, how He ended up putting all this together. So moving on, we're still looking at our sublevels here. Sublevel quantum number, aka azimuthal quantum number. I know the $25 vocabulary word. That's okay. Just understand it's a sublevel. Okay? So there's level 1, 2, 3, 4, 5, 6, and 7. Is there an 8th level? Yeah, there is, but we're not going to worry about that. Now you notice it goes up, that the higher the level you go, the more of these sublevel orbitals you've got. You say, but wait a second, what about 5 here? You got 5G and it's like a blank, and then you got all these others here that are blank. Well, keep in mind that ground state electrons don't occupy those. Wait, what do you mean by ground state electrons? Electrons that they don't have any energy. It's kind of like Monday morning, you want to wake up because you have to go to school, but you're in such a ground state before you get your coffee, right? So, yeah, this is not occupied by ground state electrons, but these are, okay? They can be. So, I mean, an electron that's here in 7p, if they get the energy, they can jump up to 7i. Absolutely they can. But we don't worry about that. So we talked about our basic energy level, level 1, 2, 3, 4. Then we talked about our sublevels, okay, like S, P, D, F, G, H, I. Now we're going to look at the third part of the address. How is it that they're arranged in three-dimensional space? Well, let's take a look at Ash Ketchum here of Pokemon fame. You notice he has the exact same pose, but you're seeing him in a different angle. He's arranged in three-dimensional space differently. And that's what's happening with these orbitals in those sublevels. Now S, you know, it's a sphere. It doesn't really matter what, it's there, it's a sphere. You can't rearrange it. But when you start looking at things like the P sublevel, the P orbitals, if you will, okay, you notice here's P in the X, P in the Y, and P in the Z. So P in the X axis is like if I take my hat, here is my hat on the X axis, here's my hat on the Y axis, right? And here's my hat on the Z axis. So it's all depending on how it's arranged. That's what's going on. That's what's happening. So there's an arrangement that's there. With that, the Pauli exclusion principle says that you can't have two electrons in an atom that have the same exact 4 quantum numbers. In other words, the same address. You can't have that. I want to write that down. You can't have the same address. They cannot physically occupy the exact same address at the same time. It's not happening. Now, that's where his exclusion principle kicks in, because in a sublevel section, like 2p in the x direction, the most number of electrons you can have are 2. The most number of electrons you can have in 2p in the y direction is 2. And the most you can have in the 2p in the z direction is 2. Guess how many you can fit in 1s? 2. Guess how many you can fit in 5s? 2. So, and the thing is, they must spin in opposite directions. That's a pretty key idea there. Okay, with that, the electron spin quantum number, MS, that is an honors chem idea. However, for Gen Chem, you understand electron spin opposite of each other. For H Chem, you got 2 possible values, +1/2 and -1/2. Each orbital can contain only 1 electron with each kind of spin. It doesn't work. It's like this. Okay? You cannot do this. This is no. This is unstable. Okay? This is the opposite spin. Okay? That's the only way that it's going to work. Okay? Now the question comes down to is, who cares? What difference does it make? Morpheus tells us, in a meme I did create, what if I told you electrons spin opposite of each other to stay stable? See, God has thought of everything. See, all this happening by random accident, random chance? Come on. You need more faith to believe all this is an accident compared to someone, an individual being, who actually had the brains to create all of this. That's why I'm an ardent creationist. All right. So we looked at the idea of the basic energy level, our sublevel, how is the orbital arranged inside that sublevel in 3D space, and the spins of the electrons. Let's take a look at those orbitals in more detail though. Well, what shape are we talking? So we have our s suborbital here, and the probability plot for that is a spherical shape. Wait, what do you mean by probability plot? The chances of us finding the electron. It's a region. Where would we find that? Now, I do an example in class about being at a mall, okay? And I'm not going to go through that here with you guys. Talk to your friends. Now, we also have the p sublevel. Now, you have 3 dumbbell-shaped orbitals, one on each axis of x, y, z. So you have going this way, this way, this way, and separately, okay, we can handle that, but what happens when they come together like this? And again, this is where we are seeing these things happening, okay? This is true for every atom that's out there. The d sublevel, you have 5 orbitals, and if you notice, 4 of them are shaped exactly the same. I'm still wrapping my head around this one. This is a weird one, okay? So you got 2 teardrops, and then you got the ring there. And the ring is not connected to the teardrops. Not at all. Then you have the F sublevel, which looks like some kind of balloons the clown from It made. I'm joking, okay? But it looks like balloons that a party clown would go and put that together, okay? 7 possible orbitals, up to 14 electrons that are there. Now that kind of tells us a few things on that. Okay, so what I'm going to do, I'm going to stop here for part 1 of this, and then we're going to spend a little bit more time on how electrons fit in and all that other stuff. We looked at the basic idea of the addresses of the electrons, and then we have sublevels, and then we have those orbitals, the shape that those orbitals come in the sublevels, and then how they're spatially arranged, and then the spin of the electron. Your 4 parts. Basic energy level, you have your sublevel, which means you have your orbital, S, P, D, F, G, H, I. Then you have how is that orbital arranged in 3D space, and then the spin of the electron. That's the 4 parts of the electron's address. Okay, we are done here for part 1 of Chapter 4B.